Good day everyone, welcome back to my channel. Today we are looking at equations and inequalities, solving linear and quadratic equations. And today we'll be specifically solving the following system of equations. Suppose we are given an equation y is equals to x squared minus 2x minus 3 and y minus x plus 3. And we need to represent those equations graphically. Now, first of all, I'll start off by writing the equation, or rather the quadratic equation. Y is equals to x squared minus 2x minus 3. Now, what I want to do now is to actually substitute 0 where x is, so that I can be able to find the intercept of y. So y is equals to 0 squared minus 2 times 0 minus 3. Y is equals to negative 3. So what does this mean? It means that when x is equals to 0, y is equals to negative 3. So I'm going to start by indicating that point on the Cartesian plane. So when x is equals to 0, y is equals to negative 3. So when x is equals to 0, y is equals to negative 3, that's the point there. In fact, it will also be viable to indicate that at this point x is 0 and then y is negative 3. Okay, now moving forward, we just found the value of y when x is equals to 0. So what I want to find now is the value of y now, of x rather, when y is equals to 0. So given that equation, so the original equation is y is equals to x squared minus 2x minus 3. Okay, so essentially what I want to do now, I want to make y 0. So I have 0 is equals to x squared minus 2x minus 3. Now, by factorization, I know that when I factorize, I have x and x in our parentheses, and then 3, because now that's the middle coefficient is negative 2x rather, so we have negative 3, and then negative times negative gives us positive. Multiplying these together gives me positive, and then last what I have now is just simply 1. Okay, and then what it means that x minus 3 is equals to 0, or x plus 1 is also equals to 0. Sorry, let me just actually indicate this by use space sparingly. So what this essentially means that x minus 3 is equals to 0, or x plus 1 is also equals to 0. What this means also, it means that x is equals to 3, or x is equals to negative 1. So let's go ahead and plug those values. So what this essentially means, it means that these are my coordinates. So I have, when y is equals to 0, I can find x to be 3, or when y is equals to 0, I also find x to be negative 1. So I need to indicate those on my Cartesian plane. So x is equals to 3, y is equals to 0. So that's the point there. And when x is equals to negative 1, y is equals to 0. That's the point there. Now I've indicated the intercepts of the Cartesian plane, or rather on the Cartesian plane. What I now essentially need to do now is to find the turning point of this quadratic equation. So the formula for the quadratic equation goes as follows. So the formula for the quadratic, or rather the turning point of our quadratic equation. So first I need to identify what a is, b, and c are. So I know that a is equals to 1, and then b of my quadratic equation is just simply negative 2, and then c is negative 3. Remember, the original equation of a quadratic equation is y is equals to ax plus bx plus c. So where I found this, I found a. In fact, this is where a is simply just 1, the leading coefficient there. Right. And then b is negative 2 in this case, and then c is just simply negative 3, given this original equation that is given there. So now to calculate the turning point, so I'm going to have Tp is equals to negative b over 2a. So remember, I'm finding x in fact here. So negative b, so I have negative substitution. I have negative 2. This is what I'm using here. Divided by 2 times this a here, 2a. So a in this case is just simply 1. So x is equals to negative multiplied by negative 2 gives me positive 2, and then 2 times 1 gives me 2. X is equals to 1. So what I need to do now is to go back to the original equation. So our original equation was y is equals to x squared minus 2x minus 3. So essentially what I need to do now is to just simply multiply x in place of where x is, to place substitute 1 where x is. So y is equals to 1 squared minus 2 times 1 minus 3. Y is equals to 1 times 1 gives me 1, minus 2 times 1, or rather negative 2 times 1 gives me negative 2 minus 3. Y is equals to 1 minus 2 gives me negative 1 minus 3 gives me negative 4. So what this means, it means that the turning point is equals to where x is 1, y is -4. So let's locate that point there where x is 1, y is -4. So this point is the intercept of this coordinate here. Okay. So now I found, in fact, let me actually do this. So remote turning point TP is 1 and our y is -4. Okay, so I'm gonna need that space to highlight that. So I'm gonna actually raise this side here. Okay, so I know my turning point is at this point here. This is my turning point of my quadratic equation. So I know my turning point is at this point when x is equals to 1 and y is equals to -4 at this point here. So what I need to do now is to start constructing my quadratic, or rather representing the equation or quadratic equation. First of all, I start with the quadratic equation, then move on to the linear equation. So in this case, I first need to rewrite my original equation. So it's y is equals to x squared minus 2x minus 3. So let's see what happens when y is equals to, say, -3. So when x is equals to -3 rather. So let's see, let's substitute -3. So we have -3 raised to the second power minus 2 times -3 minus 3. Y is equals to, so 3 times 3 gives me 9 minus -2 times -3 gives me positive 6 minus 3. So y is equals to 9 plus 6 gives me 15, subtract 3 gives me 12. Okay, this is way beyond our scope because of the Cartesian plane, or rather the scope of the scale of our Cartesian plane. So let's look for values such as 2. Okay, 2. Let's see what happens. Let's see what happens when we substitute 2. So we have y is equals to x squared minus 2x minus 3. Let's now substitute 2 in place of x. So we have -2 raised to the second power minus 2 minus 2 minus 3. Y is equals to 2 times 2 gives me 4. And then -2 times -2 gives me positive 4 minus 3. Y is equals to 4 plus 4 gives me 8 minus 3 gives me 5. So in this case, we can clearly see when x is equals to -2, y is equals to 5. So let's locate that point. I'm just going to stick to the same color. In fact, let me use a blue color here. Those are just basically intercepts in pink. So negative 2 when x is equals to is negative 2, so here we have negative 2 and y is 5, so that's the point there. Let me use it, just simplify the space, so that's the point. Okay, so let's see what happens when x is equals to negative 1. Let's substitute that into our equation. So we have to test all of these so that you can be able to find the exact corresponding coordinates. So let's see what happens when, so let's see what happens when x is equals to negative 1. So x now this time is negative 1, and then minus 2 times negative 1 minus 3. Y is equals to 1 times 1 gives me 1. Negative 2 times negative 1 gives me positive 2 minus 3. Y is equals to 1 plus 2 gives me 3. 3 minus 3 gives me 0. So when x is equals to negative 1, y is equals to 0. Now we need to locate that point as well. When x is equals to negative 1, y is equals to 0. So that's the point I've already indicated it there. So let's see what happens when x is equals to 0. We saw that that's the intercept. So when x is equals to 0, y, the intercept is y. So that's the point there, already indicated. That's already indicated there. Okay, and then we know that this is our turning point. This is our turning point. So turning point, the graph needs to turn there. And then let's see what happens when x is positive 2 now. So when x is positive 2, so we take a calculator and check. When x is positive 2, so we have 2 times raised to the second power, multiply by 2 times 2 minus 3. We get negative 3. So that graph intercepts there. So basically this is the point here. This is the point here. Oh, sorry. So that's the point there. So let's see what happens when x now becomes 3. So you can just simply substitute positive 3 in place of x in our quadratic equation. So we get 0. So when x is equals to 3, y is equals to 0. So this is the point there. Let's see what happens when you substitute 4. It's very important that one does this consistently. Okay, so we have 5, positive 5. When x is equals to 4, y is equals to 5, so that's the point there. Now essentially now we are almost done with our graph. So what you need to do now is to actually just simply join all these points, the indicated points. So we start off there. So this is our graph starting off the, so it passes through where x is equals to negative 1 and then y is equals to 0. It passes there where x is equals to 0 and y is equals to negative 3, and it turns turning point at when x is 1 and y is negative 4. And this is our representation of the equation. Y is equals to x squared minus 2x minus 3. So now we are now done with our quadratic equation, so we just simply need to look at the linear equation, because you are given a linear equation here. In fact, let me not, just be careful. So we have our linear equation there. So we need to also work that out. So now, essentially now, we are technically done with this calculation. So all you need to do now is to actually equate the two equations together to see where they intercept one another on this Cartesian plane. So what we need to do now is to write our quadratic equation. So we have our quadratic equation is x squared minus 2x minus 3, and remember now this y, in fact let me work it out here, y is y minus x plus 3 is equals to 0. So what do I need to do? I just want to remain with y on one side. So I have y is equals to, x will move over, the equal sign becomes positive x, so it becomes just x, and then so does positive 3 becomes negative 3. So essentially now what we have now, we have x minus 3. So I've just equated the quadratic equation with the linear equation. So I want to see where they intercept, or where both of these equations intercept. So I'm going to actually now bring everything on over to one side. So I have x squared minus 2x minus 3. X minus 3 will become negative x plus 3 is equals to 0. So what I want to do, I want to find the value of x where on the Cartesian plane, what happens when the intercepts of these, of the parabola and the linear equation. So x squared, so we have negative 2x and negative 1x, so we have negative 3x. So notice these cancel out because negative 3 plus 3 gives us 0. So all I remain with 0 is on the side. So I have now x squared minus 3x. So common factor is x. So I have x minus 3 is equals to 0. So in this case, x can be equals to 0, or or x minus 3 can also be equals to 0, or you can also say x is equals to 3. So where x is equals to 3, that's what we want actually. When x is equals to 3, we know that y is equals to 0. So this is the point essentially. This is the point. In fact, let me mark it with a different color. When x is equals to 0, y is equals, when x is equals to 3, y is equals to 0. So this is the point here. Okay. So lastly, we can just simply use the linear equation to find the other intercept along the y-axis. So by doing that, So this is x. So by doing that, so we have our linear equation. So our linear equation goes as follow: y is equals to x minus 3. So I want to know what happens when x is equals to 0. What is the value of y? So y is equals to, so substitute 0 where x is, minus 3. Y is equals to negative 3. So when x is equals to 0, y is equals to negative 3. This is the point here. So what I need to do now is to just simply join our two coordinates. Okay, these are the two coordinates here. That means for a straight line, linear equation. Oh, sorry, need to make it clear. So this is the line. So this line represents y is equals to x minus 3. Now that I've solved the system of equations of the quadratic equation, y is equals to x squared minus 2x minus 3, and y is equals to x minus 3. And I've also found the intercepts of those two equations. And that brings us to the end of our presentation. Please like, share, and subscribe to my channel. And please don't forget to drop the comments below. Don't forget to practice mathematics. With practice, this exercise will be a walk in the park. Thank you for watching. Goodbye.